All right. Good morning, good afternoon, good evening, everyone. And welcome to the volume 8, number 8 of the Knowledge and Experience series. My name is Jacqueline, and I'm excited to moderate today's insightful discussion on digital twins and smart transport for sustainable cities. Across the world, cities are overwhelmed with traffic congestion, insufficient public transport, flooding, and weak data for planning. At the same time, emerging digital technologies like real-time flooding and weak data systems. At the same time, emerging digital tools like real-time traffic analytics, digital twins, and smart transport systems are helping cities transform. How they are planned, moved, and grow. Today, we have four outstanding panelists or experts in sustainable transport, engineering design, technology, innovation, and urban infrastructure who would help us unpack this topic. Now, allow me to briefly introduce our panelists to you. On our panel today, we have Sarah Aguji. Sarah is a sustainable transport specialist with deep expertise in infrastructure financing and resilient mobility system. We also have Rudy Aitinga Sule. Rudy is an engineer and technologist from Siemens Ghana, merging engineering with IT innovation for smart infrastructure. We also have with us Yazan Elauzi. Yazan is roads and transportation engineer with Aji in Jordan. He's an expert in design technologies and complex transport planning. We have also with us our colleague Goslav Adum Duncan. He is the manager for civil infrastructure and a transportation planner at Construmat Africa with frontline expertise in project delivery across Ghana. Our panel, thank you all for joining us today. Without wasting much time, we will dive straight into our panel discussion. So I would start with this opening question so that we all understand what digital twin and smart transport is before we dive into the main questions. So cities like Singapore, Helsinki, amongst other cities in the global north, now run virtual replicas of their transport systems, digital twin that show real-time congestion, simulate traffic before major roadworks, and even predict accidents. Could each of you give your take on what digital twin smart transport means in the context of urban infrastructure and what essential tools can be integrated in our transport system to function effectively? I'll start with you, Rudy, if you're on the call.
Yes, hello, good morning, everyone.
Good morning. Rudy, please, can you speak up a little? We are struggling to hear you.
Okay, is this a bit better?
Yeah, thank you.
Okay, wonderful. Good morning to you, and then good morning to your audience.
Morning.
Digital twin, it's not a new technology. It's been in existence for a very long time. And it's in a broad sense, it's basically a replication of the physical world in a digital space. So basically everything that you see in the physical world, it's replicated in the digital space. If there's a change in the physical world, it also shows up in the digital space at the same time. So there's no delay. So it's basically used to, let's say, model an entire system. It's like your CAD, your computer aided design, your 3D modeling, but with the added benefit that it is updated continuously in real time based on any changes that happen in the physical space. So if there's a change, let's say we are taking the transport system, if there's a change in the traffic data in your digital space, you'd have an equivalent change in that information too. If there's a change in the number of vehicles on the way, you have the same change that is replicated in the digital space without needing to do any updates manually by any human being. Now, when you bring it to the digital space, sorry, when you bring it to smart transports, it's basically using all these informations that you've collected from the physical sensors and all of the instruments that are measuring all the information and using that information to make the users of these transport systems and these urban systems better. So, for instance, if you take the information that is traffic information and you feed it into the digital space, you can apply a lot of the new AI models, the complex systems that are able to divert traffic to other parts of the road. So, in a few words, I think this is what I can say about the digital twin.
Right. Thank you. Thank you for highlighting that this is not new and has been in existence for a very long time. I'll move to you, Sayram. What is your take on this?
Hi again. Thank you. I would just build up on what Rudy said. So the digital twin essentially in that digital space, what you would have is you have information on your infrastructure, that is your road, your signals, your traffic lights, your street lights and everything inside that space. And then you also have, the systems that communicate with the road users and everything, all of that. You have your operational characteristics in there. And based on this, you are able to know
I
real
can
time
yes, and I know.
you're able to know real time what is happening on your road. So say, for example, if you just take a stretch of road, a typical one, let's say any of your trunk roads with say 5 intersections, at every time, because your real life infrastructure and vehicles and what is happening on your road is communicating with the digital world, you are able to tell where the traffic is, where the congestion is. Then based on that, you're able to make decisions as to whether to increase your signal timings, to alleviate congestion at one part or to divert traffic to another part. You have, in terms of the tools you can deploy, just take your typical pavement, for example. You can have inductors embedded in there that's able to tell you at every point in time what is the state of your pavement, what is the traffic load that is using the pavement. And then with this, you're able to do predictive modeling to see how many life or how long does your pavement stays before it start degrading, or when do you schedule your next maintenance. So all of this digital twin, I think, is a very powerful tool to help states and city authorities to make, budgetary allocation and investment decisions and optimize the system as well. I think we'll be discussing that further down.
Yes, thank you for that, Sayram. I'll move to you, Goslav. I would be so happy if my panelists, you would turn on your camera so that if you're in a position so that our audience can see who is speaking. Thank you.
Good morning, everyone, and thank you, Jacqueline, for the opportunity. I'll just also continue, maybe touch on some of the things that my colleagues have already mentioned. So when we say a digital twin, we're actually just referring to a virtual system. Like the name implies, it's a twin, so you expect that it would be something of a clone to what the physical or actual infrastructure is. So it's also driven by data mainly, because everything represented on the computer is just ones and zeros and just data. And like we know it, it's just to allow for simulation. It allows you to simulate and also to conduct your forecasting. And then the main objective of a digital twin really is just to optimize the system. So I'll leave that definition of the digital twin at that, and also briefly touch on the smart transport. Smart transport, as we know, it is just making our transport ecosystem a very responsive one, and one that reacts to instantly to data or to pressures. So when we look at smart transport, we are looking at sensors and then an analysis of data. And the systems that are intelligent, that is, if as the transport system sees that something is wrong on the road, it should be able to react and respond to it. The objective of that also is just to be able to monitor itself as a system and does not really need the influence or intervention of human beings as much as we do, especially in our part of the world here currently. It's also supposed to be able to self-optimize, and which means that if it sees that I can give this number of seconds to this directional traffic, so that it releases the load of the road for the road to be more sustainable or to be more resilient, then yes, that system will do that. It should also be very responsive, so that if there's an accident on this part of the road, in a second, the system should be able to respond to redirect traffic, to be able to redistribute the traffic so that it doesn't cause any congestion or any adverse impact. And also it should be integrated because then if you want a system to be able to work on its own, then information on even the road capacity, we are talking about the available transport means, and the demand should all be information that the system can easily access to be able to regulate the system. For essentials that should be able to make digital systems or digital twins and also smart transport to really work, then we are talking about the Internet of Things, and to be able to access data. You also need the AI or machine learning to be able to analyze this data that it continuously receives to be able to make decisions and then give a very responsive reaction. We also need GIS for positioning and position accuracies, for the system to be able to tell where and what exactly is happening at a particular time. Then you also need high connectivity, and that is something I'm sure we'll delve into later. And we're also looking at cloud and edge computing, because this data that you are talking about, you see it just as one and zeros, but they also occupy a huge spaces. So we need a system that will be able to collect this data, hold it, and be able to give it to the system to access as much as possible. And a very critical one to this is also cybersecurity. And I would just draw the curtains down on this by saying that digital twin just it's all about visibility and then foresight. Whilst smart transport, in my opinion, is more about being responsive or providing responsiveness and then optimization. Thank you very much.
Thank you so much, Godlove. I'll quickly move to Yazan to share his thoughts as well.
Actually, I have some problem with Zoom. I don't know what the problem. I will start from my phone, actually. It was connected from the laptop, but now there is a problem. I don't know if you see my picture or not. Can you see
We
my
can see
camera?
clearly.
Yeah?
Yes.
Perfect. I will put my mobile here and start without laptop. At the beginning, I want to thank you, Jacqueline. I hope you're good. And I will thank you to the Construmart for inviting me for this important discussion on digital twins and smart transport for sustainable cities. For this question or identification, let me tell you how I identify digital twin and smart transport for my clients. Actually, I'm always tell them that the digital twins. It's like a time machine.
Recording in progress.
I told you there's a problem with. It's like a time machine. Let's. Sorry for that. It's stop.
Let's see. Can you?
Yes, I can see you on two devices. So if it's possible to mute one.
Yeah, because that
So
I'm
that-
closing one of them. Yes.
Okay, sure. Thank you.
Now good. Digital twin is, as I mentioned, and as I'm always tell to my clients, it's a time machine. It's let you test tomorrow's mistakes before they cost millions. And the smart transport, it's an intelligence system. It's nervous system to your city, senses, things respond. If we integrated them together, they let you solve problems before they become unreal. And when you do that, way you will infrastructure more sustainable for everyone. Based on you, how you introduce me for the whole audience and panelists, if you can allow me, I can maybe give them, let them show that in real project, in a practical way, not in a theoretical way. I can share my insight from one of project we did, and now it's on a reel, and it's start operating. I will start with the exhibition center challenge. When we talk about exhibition center or any convention center, we are talking about a huge events, 20,000 every two will arrive within 2 hours at the same time. The real problem on any exhibition or convention center, not the building itself. It's the main problem how we can guarantee there is no traffic congested and the gridlock for the whole entry area. Traditional engineering, we use average daily traffic, growth factor, traffic impact on the entry area with some assumptions and on some assumptions, and we hope it's work. But hope isn't engineering. But when we use digital twin, we can make a huge expectation, a huge what if trials before we built anything. For this project, we built a digital twin for the entire district, let's say about 20 kilometers around the proposed location for the exhibition center. It's a living digital copy of every road, intersection, signal within 10 or 20 kilometers. We modeled how people actually drive. This is important, how people actually drive, not how they should. After that, we checked and simulate and asked the digital twin we prepared to show us the future. What happens when 20,000 visitors arrive at the same time or within 2 hours? Where do bottlenecks form, let's say? What if it's rain? What if there is an accident at the highway or at the near district, or if there is any event or concert at the same area? Then we ask it to show us the future. What happens if there is any growth for at the company, at the area, at the city? Because that we run based on digital twin, it's easy to run thousands and thousands of scenarios. What if? A digital twin will detect for you problems we'd never see with any traditional method, with the engineering method, such as not only about the traffic congested and the impact for the whole areas around the exhibition center, and also inside into the design process for the entire of the exhibition center. Let's say parking queue stretching onto highway, distance between intersections, the dangerous for pedestrian circulation, everything. The most important thing of that, by using digital twin, we found every problem digitally without any cost. It's only the cost of using a computer, and we can solve the whole problem without any extra cost because we are still using computer. Because that's so we and this the exhibition center, which is a huge one, will increase the economical the economical rate of the country. We redesigned more entry lanes, better parking, upgrade the whole district and any affected intersection and road. But I'm just now finished talking. We used only digital twin. How we integrate smart transport on that? Because we didn't stop on digital twin and how we solve the problem. How we can reflect that not for 1 year, as I mentioned, the digital twin. It's not give you the at the moment or the for 1 year or 3 years. It's a live video show you what's happened on for 20, 30 years, because that to make sure the success of the project for the whole life cycle of this project, we didn't stop design on that. We built an intelligent system that adapts in real time. What's the meaning of that? We occupy the whole network with sensors, cameras, monitoring, everything continuously to show us what's happening in the real smart traffic signals, which is adjusted automatically if there is an heavy traffic coming from north or from south, give green more there, variable message signs. The conclusion of using digital twins and smart transport, that we will solve the traffic, the problem years before it's happened. This is my definition. I try to give a practical insight about digital twin and smart transport.
Right. Thank you
Thank
so
you.
much, Yazan, for all that you've said and other panelists have said. Digital twin simply means making real-time assumption with real data or right data to assess how the system will look even in the long term. This takes us into the next theme, which is real-time modeling. So I'll move to you, Sarah. In the global north, countries like the UK use digital twin modeling has helped them predict infrastructure failures years ahead. That you've all spoken about. So saving millions in maintenance costs. So I want to know, how does the real-time modeling capability of the digital twin fundamentally change our ability to plan and finance sustainable transport projects compared to the traditional planning models?
Thank you, Jackie. Like I mentioned earlier, I think we started the discussion a bit on this one. Like digital twin is a very powerful tool for asset management, and countries like the UK, Europe, Portugal, and all have made very advanced decisions on using all of this. So I'll just take a case of a pavement management. Okay, so as opposed to traditional or conventional engineering in Ghana, in places like Ghana here, where we construct the pavement and then we wait for the pavement to deteriorate and then we go do maintenance. So it's more like firefighting. You have countries in the UK like this doing very predictive modeling. So just like we all been in the discussion, what you have is, once you construct the pavement, you have your inductors, and then you have sensors embedded in this pavement. So over the life cycle of the pavement, you are going to be collecting information on cracks, on deflections. You are going to be having information on the load that are using the pavement. Over time, you would have been able to predict or have sort of a degradation model which you're able to get from this pavement. And so states or cities know that, okay, this road, based on the traffic that is using it, in the next 10 years is going to develop cracks. The states or the city authorities would have set a threshold. Like in Ghana here, we collect a lot of information on pavement, and then we have scores. So you have your pavement to be 10%, depending on the number of potholes or cracks that are on it. So when you have your pavement after construction, it's like 100%. It's in excellent condition. And then over time, it degrades. So in UK, countries like this, where they have a score for their pavement. So let's say the city of Nottingham doesn't want any of their pavement to go below 70%. So that means the failure shouldn't be at 70%. Then you have tens and thousands of roads that, based on digital model tools embedded in this pavement, you know the state or the condition of each of these pavement at every time in real time. Then the state is able to plan and say, okay, we have 20 cedis or we have $20. How many roads can we fix with that? So you're able to do budget allocation and you're not firefighting. You're able to predict, you're able to get loans and all of that against this. So this time around, you are in control of how your pavement is performing, and you don't have to have people going on demonstrations that they need their road fixed, because once you're able to tell in real time what you can manage, you can control, right? So once you're able to know what is happening in real time, you're able to address this. A typical example is, even for example, if you take pavement, if you take congestion, for example, where in any real time, you know what is happening on your road, you know who is where and how the city is moving. So in big cities where they have a city traffic management systems, I think we have one in an urban roads, where you have giant screen and people are monitoring traffic in real time. They know what is happening at everywhere. We have cases where vehicles get broken down on intersections for like weeks and nobody even know what is happening, causing accidents and killing people on the road. It's estimated that by the time, in some cities, if you live up to 70 years, you would have used 10 years just sitting in traffic. Okay, that's a lot of waste of productive time. But if you have a city that is in charge, that knows what is happening on their road real time, it helps with budgetary allocations. You're able to make decisions.
Right. Thank you, Seram. It seems we've lost you. So I'll quickly move on. You've set a lot of bases for our next question, which will go to you, Gustav. Where do you see most immediate or practical application of these technologies that we've been talking about in African cities to address the chronic issue such as congestion and poor service delivery on our roads? Thank you.
Thank you very much, Jacqueline, and thank you, my colleagues, for setting the ball rolling on this. So generally, you see that cost can be quantified in time, in energy savings, even lives as well. And so there are a lot of opportunities available or that exist when it comes to digital twin and also having an intelligent transport system. There are lots of benefits, opportunities that exist for Africa. In Ghana, if you are not oblivious of it, you realize that Ghana has a system which is the Accra Intelligent Transport or Traffic Management System. This is supposed to help to manage manage congestion, manage traffic at major intersections in Ghana. This has been since 2023, and then I think the government is still working on it to operationalize this to full capacity. But just to also mention a few, we can talk of the bus fleet, telematics, and then passenger information systems. When you go to other parts of the world, you would realize that you could schedule or plan your trip or your travel or movement to any from one point to the other very easily and in a very integrated manner. And this is one of the opportunities that exists for us. Assuming you are coming from Cape Coast, you are going to the Ministry of Roads and Highways or Ministry of Housing, Works and Housing. You just go to your system, you check what is the next bus trip from Cape Coast to Accra, and even from that point to the Accra central part of Accra, and then even to your exact destination. In other parts, they've even integrated it to the point that it connects you from the railway system to a bus system to a bike system, and then you realize that that makes it very easy. You're also looking at digital monitoring and monitoring of the intersection and congestion hotspots. Like I said, one of the major causes of delays in our setting here mostly is the management of traffic in intersections. And you realize that sometimes it takes the intervention of human or human intervention. You have the MTTD come to stand there, and then they try to simulate in their minds how much traffic or delay will be caused if I release this route to go earlier, how much time do I assign to this direction of traffic? And it makes it very difficult. But having a system such as the digital monitoring and intersection or congestion hotspot systems, you can easily identify those inefficiencies because the system itself analyzes the demand for the use of the road in each direction, and then the opening or the supply that is available, and efficiently distributes those loads or those demands to the supplies. You can also look at illegal parking behaviors, and you can attest that in our part of the world, that is one of the major challenges when someone wants to stop by the road to just get some meal to bite into and decides to park by the road or even at a spot that is not helpful. Some of these systems could help to manage some of the situations when you know you are being monitored and that you could easily be identified and fined to an amount that you could easily avoid. I'm sure that would be a motivation for people to avoid congesting the road in such manner. Looking at also smart fare collection and payment systems. Once again, in our system, what you do is you enter a bus. Sometimes you don't even know the fare to where exactly you are going, or even if you do, the operators of the vehicle decide that it is very late and there's high demand, so I would want to now charge you 50 cedis instead of 30 cedis. And what some of these systems could do is to streamline or to manage this situation, that you have a payment system that has already specified some of those costs, and so simply by a swipe of your card, you enter the bus, you swipe your card, you make your payment, and then you go. It reduces the human interaction as much as possible. They are also looking at low cost IoT road conditioning monitoring, and I think Saram hinted on that briefly. And it is very important because if you don't know how your road is dynamically impacting your road or causing deterioration to your road, and you cannot have human beings standing by the road from 24/7 to identify that, oh, there's this crack that is appearing over here. But a system could easily detect some of those things. Tells you, oh, there's a minor crack over here. And considering the traffic load that uses this part of the road, you expect that in the next 30 days you would have a pothole over there, or in the next 1 year you have this defect over here. And that will help the government and the agencies that are responsible to easily identify some of these things and address it. Why should it have to be Africa? Or why are we even considering that these opportunities are right for Africa and Ghana? We are saying that there's a low cost impact if we consider it right now. Also because we are now developing, and also the magnitude or the load of our infrastructure is not as much as the developed countries right now. So if we take it from this point and then manage it very well, then we can be able to build on these systems to be able to adapt to the scale of our expansion in our various in our various infrastructure aspects. It is also scalable so that it is not like a system that, okay, I've gone for it. It manages 30 people. And so even though I have 2 people who are using the system, I make a loss because there are 28 people more that are not using the system. But you realize that some of these systems are also scalable. So when you apply some of these systems, for example, in Accra, and then you have a success story, then you also have the experience and then the history to be able to help you to scale it to other regions and to the nation, a nationwide scale as well. You're also looking at the immediate visible benefits. If you have a transport system that is managed by an intelligent system and it's able to tell you that if you use this route, you are going to delay by 20 minutes, but rather use this other route when you have your user interface information system that guides you to choose your route carefully, or even the time of the day that you decide to step out of the house if it is not urgent or depending on what you are going to do, then that helps you to reduce your travel time. And then mind you, like I said, some of the cost savings are in terms of time. We are talking about energy savings. Energy savings, if you are supposed to get stuck in traffic for about 30 minutes, it means that you are burning more fuel for nothing. Also, even the risk of your life, losing a life, especially when you are traveling a certain way, there's an accident ahead, and the system can be able to prompt you ahead of time that, oh, there's a certain obstruction in this way, or the road pavement has suddenly collapsed at this point. Then it guides the user to be able to know that, okay, this route is not good, let me use this other route. And also, it enhances public trust in the city agencies. I'm sure if we were asked how some of the agencies are working based on our perception about how they are managing the systems, you have your own feedback and your level of confidence or trust in some of these agencies. But if we reduce the human interference or the way that our agencies have to go about the traditional way, going about collecting data, which they need a lot of time to collect before they even come back to analyze, before they apply the scales of priority to it to determine that this road is what we are supposed to go for or not. If you have an intelligent system, it will do all that for you. That based on this level of deterioration on this road, it is recommended that this road is improved in this manner. And also what it does is, and as we know, if road is deteriorating and then you intervene at an early stage, what it does is that it increases the lifespan of that road exponentially as compared to when you wait for it to deteriorate and then you go back to work on it. Even that also gives you cost savings as well. I would draw my curtains down on this point and then
Right.
see
Thank
to
you
you.
so much, Goslar, for that. From all that you said, what I took from it is that there are a lot of opportunity for us here in Africa to start small, and I hope implementers will take this up in their planning our transport system. So now we are moving on from definition to more practical implementation. But before we delve into that, Rudy, I want you to help us. What essential technologies must be integrated for transport-focused digital twin to be more functional?
Okay. Hello once again. Hope you can hear me better this time.
Yes, I can hear you.
Wonderful. So, digital twin, it's all about data. So the technology required is basically technology required to collect data. So like my co-panelists have already mentioned, you need a lot of sensors, including the induction, the loop detectors to be able to determine the number of vehicles used in a particular route. The cameras too, to be able to identify visually that vehicles are using a certain route. It's not only limited to vehicles, you could also use the train system. We don't have that in our part of the world yet, but we also have sensors to determine the train movement and all of that. Radar. Now the new cars coming around, they all have radar and LiDAR sensors that are able to determine proximity between vehicles. All of that information feeds into the digital twin system to be able to replicate almost perfectly what is happening in the physical world. I mean, these sensors don't only have to measure the vehicles that are using the road, we also could use sensors that measure just basically the environment, weather information, stuff like weather information. You could also measure people, how many people are around. You could measure load on let's say a bridge, how much load is being sustained on the bridge, the strain and all of that information. I mean, we on top of all of this information gathering, there has to be a reliable way of carrying this information to the central point where the data is collected. And that brings us to the good internet connectivity. I mean, in our parts of the world, we have really spotty internet connection in a lot of places. And these are some of the foundational technologies that we need to improve upon. Also, electricity, energy. You can't have all these sensors running around without source of power. So all of these technologies have foundational benefit that we need to all look at before we're able to actually implement something like a full digital system that is able to mirror exactly what is happening in the real world.
Right. Thank you so much, Rudy, for the insights. And to our audience, please, if you have any question, kindly drop it in the chat box and I'll direct it to the specific speaker to answer the question. Now we want to hear an example. I mean, we've heard a lot from all of you. We want to hear an example of a project that has applied these technologies to improve its resilience and its measure project outcome. I'll direct it to you, Yazan, since you have worked on real life project that has employed some of this technology. Kindly share the experience with us and how this can actually be achieved in real life. Thank you.
Thank you, Jacqueline, and thank you, Godo, for the fruitful and amazing information you shared for everyone. You talked about everything, about AI, about smart system, everything. Let me start on a real project which we faced in our real life, which is the name of this project before we solve the problem. The name of it, the Impossible Corridor. I will start like telling a story. Imagine that the most critical and vital corridor in your city, which is the lifeline, all the time congested, the average delay not less than 45 minutes, the average annual daily traffic of users on each side more than 400 vehicle per day. And this vital or critical corridor, it's a primary one because it's serve the four function. It's connecting between it's a highway connected primary north and south of the city and the country. It's the main access for the international airport. It's the backbone for the internal transit, let's say, and it's the spine also for the public transportation, and also it's the most important commercial street at your country. Actually, we have this in our country on the region. And it was shocking that it has nine main intersection. We cannot close any of these intersection or the road, not even for 1 hour. No space for make any expansion or widening for this road. And also we need to serve a public transport to reduce the congestion and the pollution also for sustainable. At the beginning of this project, there is a lot of consultants tried to solve one of these functions. Everyone said you can choose public transport or through traffic or the internal transit. Let's say if we proposed a tunnel, you will serve the through traffic. If you design a monorail or a PRT, you will serve only public transport, and it's so costly. Because that we tried to use digital transformation, digital twins, how we can integrate and serve the four functions together. And our solution, which is a part of symbiotic infrastructure, we proposed, let's say it's the length of this spine, it's about 16 kilometers. We proposed and also designed, and now it's constructed and operating a 16 kilometers elevated intelligence corridor. It's an intelligent corridor, one system serving the four functions managed by intelligence, let's say. I will start how we, as I mentioned at the beginning of this project, we cannot close any part of this road, especially the intersection, even 1 hour. How we use digital twin to solve the design, the construction, the operation. I will start with the construction. We use the digital twin to simulate the construction, because that our design for the piers or the supported columns to make sure about the constructability. We proposed and designed the whole piers of the project at the median of this road, and for each intersection we proposed shift and realignment for the elevated bridge, not to access center of the intersections or the underpasses or the existing intersection. It will be shifted, and we did a huge realignment at each intersection, because that we can achieve elevated bridge, the constructability of a bridge without touching and block the traffic. We tested everything digitally first before we start the construction. We built above live traffic, let's say, keeping the whole city moving, etc. When I talk about elevated bridge, you will ask me, someone will ask how you solve the public transport and the BRT problem, because the elevated bridge, it serves the through traffic, the internal transit, the access for the airport, but also we propose to share the 2 lanes on each direction, the same lanes, no separate BRT dedicated lane. How we can integrate public transport or BRT with the vehicles, the through traffic, the internal transit. We here use the intelligence. The smart transport shines here. We occupied every 100 meters, sensors, cameras, to can operate, and if we have a PRT bus approach, AI created virtual priority zone. That means it's not a dedicated lane, it will be AI priority zone. It can, by AI, adjust speeds for the surrounding vehicles, open gaps, not physical lane, it's a priority zone, as I mentioned. And also, we are talking about the huge cost for elevated bridge to reduce the congested and to reduce the carbon emission, everything, because that we propose this the construction, the initial capex of this project to be as a toll road, but toll road, that means sometimes a closed system, not open, not a free flow system, because that we also proposed a digital tolling RFID, which is and QR code, and also ID plate recognition to make sure that there is no new stop and congestion. The system manage demand in real time. We are talking about a lot of sensors, a lot of cameras. If there is expected to decrease the level of service at the elevated bridge will increase dynamically, the tariff will increase, it will decrease, the whole system will be integrated together. Meanwhile, ground level stay functional. We didn't touch any of the interchanges or the intersections, and also we increase the level of service for the ground road, because we take 20%, 30% based on the current situation and the condition to the elevated bridge to serve through traffic and the BRT also. The conclusion of that, what everyone said impossible, become reality if we use digital twin integrated or evolved with smart transport. If we
Right.
if we look around us for the region, there is a lot of cities now started to the smart system and to use the twin, digital twin, and to integrate it with smart transport. Thank you.
Right. Thank you so much, Yazan, for creating that scenarios for us and how you use digital twin to visualize and plan the construction of a very heavy traffic road that connects to various necessary services. Now, because we have almost exhausted our time and we also want to hear from our audience, we would take questions now. So please, if you have a question, and you wish to speak, kindly use the virtual raise your hand button and you'll be called to ask your question or a contribution. And if you want to use also chat box to ask your question or contribute to the topic. But whilst we wait for the questions from our audience, I would like to have one sentence from each of you, our panelists, or one key takeaway. What is the single most important action for us, all of us, can take today to accelerate the adoption of digital twin and smart transport technologies in our region? Yazan, you are not within the Africa region, but also in the Middle East region as well. So please, I'll start with you, Rudy.
Yes, one sentence. Okay. Policy.
Rudy,
Policy,
can you hear
and
me?
then, yes, we can hear you.
Okay.
So, policy and good financing models. That's my one sentence. This is what we need to do in order to facilitate the better adoption of digital twin.
Right. Right. Thank you. I'm tempted to ask a follow-up question to you, Rudy. So please, what kind of frameworks can guide all cities plan smartly? Because with the use of very large data, internet, there are lots of risk associated with it, such as cyber crimes and other risks. So what kind of policies can drive this very successfully within our regions?
So to start with, because of the huge amount of data you're collecting, and basically with the cameras included in the data collection, you have so much private information about people who need good cybersecurity laws. I think we even have one currently being deliberated in Parliament with the Cybersecurity Act. We need to implement good cybersecurity laws that will regulate the information access, who can access information, who can share that information, and what that information can be used. Aside the security aspect of it with the data collection and the data gathering, we also need good policies in terms of financing. We need to be open to accepting business models and financing models such as build, own, operate, and transfer, where the public and private sector would sort of collaborate so that they can give some licensing for these private sectors to actually do the building, because the cost is usually huge, and leaving that alone to the public sector to implement is quite a lot, just as a summary.
Right. Thank you so much, Rudy, for that. Before the other panelists come in, let's take a few questions that has come in. Joseph says, good morning. How can ITS help reduce environmental impact? Gosla, will you take that for us?
Thank you. Yes. How does ITS help? ITS, Intelligent Transport System. It could come from so many angles. We are talking about life savings, and human beings are part of the environment. We are also talking about waste or emissions from vehicles. And when you stay in traffic for long, the health impacts that come from staying in traffic for long, traveling for too long a time, the socio-economic impact, which is also related to the environment as well, because then when you have good packets, then you'll be able to live well, you'll be able to impact your community. So in short, there are a lot of benefits, there are health benefits, cost savings, there are savings in time that you could use to rest, will not be spent in traffic. When you have intelligent transport systems, you are less likely to hit someone because your vehicle system will prompt you that there's someone ahead. You are less likely to take the money that you'd have used to pay your children's school fees to give to someone to repair his vehicle just because you have hit or run into it. So there are a lot of benefits, even for the government as well. The burden of government to come and continue repairing roads that have gone through its full life cycle, and trying to revive it is also reduced because then there's lesser amount or budget spent on keeping our roads in shape and keeping everyone happy as well. Thank you.
Right. Thank you, Goslav. There's another one from Chelsea, and Chelsea says, thank you to all our panelists. And the question is, how can African cities, especially those with limited digital infrastructure, begin integrating smart transport solution in a cost-effective and sustainable way? Sarah, can you take this for us? You touched on this briefly before you drop off. So if you can take this one for us.
So I think this question was answered by Rudy when he mentioned policy. I think for African cities, first of all, you need a policy. The policy will spell out your vision, because then from that, once the policy is spelled out, then you start discussing how do you mainstream this into your designs and everything. So first is you need a policy that spells out the vision. We need to integrate, smart cities, digital twin into our designs. And then from then we'll flow on how do we finance all of this? What are our targets? So then once your policy is set, you start setting your targets now. Okay, we want our roads to be at this performance levels. How do we get to those performance level? What are the thresholds? What are the indicators and all of that? So once the policy is set out, you then start from there. Okay. But I think as at now, some of us have started implementing some of this. There's HDM4 that African cities have been using to do their pavement designs, looking at the economic impact, maintenance planning and all of that. I think and Gosway, I think Goslav also mentioned it at one point. You start small and then you learn very fast.
Okay. Thank you, Sarah, for that. There is someone's hand up. Ernest, please, you have 30 seconds to ask your question. Ernest, please, can you unmute and ask your question?
Yes, please. Can you hear me now?
Yes, I can hear you.
Okay, so please, my name is Enes, and I'm a student at University of Mines and Technology, UMass campus. So my question is, following the recent incident on the Tema Impakanda Railway, a man was struck by a train after he refused to move away from the tracks following several warnings from the one controlling the train. So I want to ask, in the context of digital twins and smart transport for sustainable cities, how can we effectively engage, respect, and appreciate these technologies, especially in communities where risk perception may be low?
Okay, Ernest, you went off at a point. I don't know if our panelists catch the full question. I didn't. So if any of you catch the question, can you help?
I think he was saying how in the context of digital twins, if I get it correctly, how should we have been able to foresee this? I think yes, because if our systems were connected with internet and everything, with your cameras and sensors, you would have, catch, or the sensors would have picked that there's somebody around or there's movement on the trail or track that shouldn't be there. And then again, your systems are automated. They're able to, is train. Imagine for the train, for example, train radar able to pick signals a few meters ahead of it, so it would have engaged the braking system before it got to the point of hitting the person. So that should be my take on it.
Right. Thank you, Sairam and Ernest. I hope you are satisfied with the answer. So I'll now leave the floor for the one sentence. I'll take from Yazan. Yazan, please, can you unmute your mic and speak?
Thank you, Jacqueline. Thank you, everyone, for the second time. Actually, the whole answers are very fruitful, but the most important thing, I will just add something for the first question. Just the question which is about we have a poor and not a good infrastructure of digital infrastructure. If we think about the whole countries all over the world, when you start, you will finish. Just start. We know that there is a very not development infrastructure in a lot of countries, but when they start, you will find how you reduce the cost of construction, the cost of everything. You will have an intelligent solution. The world now is changed because that the whole government all over the world just must start with the new digital twins and smart transport, not only on the transport, on every disciplines on construction, and also on the commercial, on the logistics hub, on the forecasting, and as mentioned, Sirom, about the world is now looking and transferring to the PPP, which is public-private partnership, on the whole disciplines, because that the whole government now must raise the flag and just to start. هلا my idioms, let's say, for this discussion, this is fruitful discussion. Digital twins and smart transport, this is important. Guarantee sustainability instead of hoping for it, which is based on the traditional engineering. Thank you.
Right. Thank you so much, Yazan. Sairam, what your one sentence most important thing for us to do to integrate this in our systems?
I think I said it. You learn fast and then you start small.
Okay, thank you for that. Goslav, can we hear from you?
Thank you. While the discussions might have been skewed towards the transport industry, I think those of us also in the other industry should not be discouraged because there are very impressive success stories in flood management, building as well. So we shouldn't only skew it to transport, which might have seemed the case. But at the end, I think data is very important. Without the data, you cannot do anything. You can have all the smart ideas and all of that, but if you don't have the data to even first of all simulate to see that it is applicable or it is reasonable what we are looking at, then it is not possible. It is also not just the data, but we also need cooperation from people, government, and once I say that also. Subtly because of the question. And so if you realize that the train is coming, the train realizes that it is safe, then all of a sudden you jump and then you get in front of it, definitely you are going to be hit. But I think we need cooperation from agencies, we need cooperation from funding agencies, we need cooperation from the government and individuals as well. Thank you very much.
Right. Thank you, Goslav, for drawing the curtain on collaboration. And thank you all to our panelists for such insights. I like the energy and the zeal at which we are talking about this. And I believe that when we get a real life situation to solve, we would all be able to apply this knowledge to solve it. Thank you all once again for the deep insight shared today. And thank you to everyone who made time to join us on this session. Digital twin and smart transport system are reshaping the way cities operate. And today's conversation has given us a clear picture of the opportunities, challenges, and pathways ahead. I'll urge all of us to continue to follow us on our social media platforms at Construmat Africa on LinkedIn, YouTube, and Twitter, and our website www.construmatafrica.com for more insights on the Knowledge and Experience series. We look forward to seeing you again next week for another insightful session, and have a wonderful day.
All right, thank you.
Thank you, Jacqueline.
Thank you,
Thank you,
Jacqueline,
everyone.
and thank you, everyone.
Thank you, everyone. Have a good
Thank
day.
you.